Thank you. Again, my name is Greg Smith, and I'm representative of HeatWorks Model 1. This is a new type of hot water heater that is like no other. It uses a totally different process of heating the water. Like our conventional hot water heaters, we have our hot water tank that heats the water either by gas or by electric. Then it's heated and on demand used. The electric heater, you have your electrodes that heat the actual water. So you have your electricity coming in, those electrodes heat, then heats the water. This unit does not do that. It skips that process. Same with the natural gas or propane. You have your heat exchanger with your flame, and the heat is transferred from the flame to the heat exchanger to the water. This model uses the water as the element to heat based on conductivity. So it does not use natural gas. It does use electricity, either 110 or 220. One more thing. The nice thing about this is that it is almost zero maintenance on this unit. Whereas these units here that I just showed you, these electric elements go out. You have sediment that flocks to the bottom of these tanks where they actually heat the bottom of the tank. Sediment collects. It will actually calcify on these electrodes. Efficiency drops off. This does not. Nothing will calcify. Nothing collects on the inside of this. The only thing that gets hot is the water itself, nothing else. And how it's done are by these graphite electrodes, as you can see. Power current is placed on these plates, these graphite plates. Water is passed through them. The conductivity of the water, which is the hardness of water, that is actually creates it'd be the resistance between the plates. That heats itself. All on demand. But basically, as this graph shows you, 36% of your water consumption is hot water. This equates to 18% of the energy used in an average home. They say this thing here, the developers have seen a 40% reduction in power usage in their laboratory, their testing. The energy devoted to water heating with M1S, this unit will save 24% of the energy used to heat the water and 20% of the water used waiting for water to get hot, if that makes sense. So 20% of the water used waiting for water to get hot, like you're waiting to turn the shower on, you're waiting for the water to get hot, you're minimizing the waste of water, which people may have heard that the EPA is kind of doing some investigating or doing some research on the hotel industry, seeing how much water is actually being used. This would actually help. When you take the water that comes into this unit, on the outside, the hot port will be 80 degrees hotter. So around here, groundwater is usually, say, 46 degrees. The temperature the out port would be 126. So it actually would increase the temperature of the water 80 degrees. Limited to gallons per minute. It's not as fast as these on-demand or these large tank systems. So you gotta use these things within a certain parameter. Here's a graph that can kind of confuse people. Maybe it won't, but it'll show you what your actual total gallons of minute demand are and what it'll actually increase the water. So you have your your in temperature versus your out temperature and what your power demand will be. This is an actual little test that I did, and I wanted to see if this thing actually worked. At 220, as you can see here, it raised it to 110 degrees at 1.5 gallons per minute. It was a good steady outflow at 220. Amperage was up, but for the 110, I kind of minimized it because of the source that we were using for electrical. We wanted to upgrade things before we bumped the amperage up on that. But we were able to get, almost 1 gallon at a steady degree, a temperature of 100 degrees. So these things do work. They do work. The applications are going to be for everything from boating, RV, camping, homes, pools, spas, jacuzzis. They're coming out with a next generation heater for pools, jacuzzis, because they have to have a different UL rating. Coming out soon. That's pretty much it. Keep your eyes on these things. They're going to be coming out.